So this video is going to be on Chapter 3, 2D motion, specifically sample problem C, so then you can figure out how to do your practice problems based off of this sample problem C. The first thing I'd like you guys to take a look at is what I have put into the next slide here. This next slide that I'm about to show you is not in your packet, but you need to write this down. This slide is going to be the steps that you're going to take in order to solve through for practice C problems. Yeah, you're going to use I guess now, where the I stands for image. In other words, draw the triangle. So based on what they tell you in the problem, you'll want to construct a triangle that makes most accurate sense. You'll also want to write down your givens from the problem. That hasn't changed. My biggest suggestion on here, though, is watch to see how your theta is sweeping. Is it sweeping downward, so like a negative theta? Is it sweeping upward, so a positive theta? Are you moving northeast, southwest? Be as thorough as possible with these givens and with the unknowns as well. Yeah, there's unknowns as in plural written here because odds are you're going to have to solve for a resultant magnitude, Pythagorean theorem, and a resultant direction, which would be inverse tan of opposite over adjacent. Little interjection here, so you know which opposite over adjacent, x over y or y over x, that you want to use based off of, did I draw as my I here? Did I draw my image as a bow tie triangle or an hourglass triangle? Bow tie triangles would be the inverse tan of y over x. Hourglass triangles would be the inverse tan of x over y. Okay. So the first thing that you're going to want to do in showing your work, and you'll see that I do this with my work too, I put a number 1. This is breaking down quote-unquote day 1 components. So the first thing you want to solve for is your x1 and your y1. So for instance, guys, in your givens, it's going to say, Sally first walked 62 kilometers at an angle of 45 degrees, blah, blah, blah. So 62 kilometers is the resultant line. You need to solve for the x and y components off of that resultant line. So to solve for your x and y components, once again, you're going to be given the resultant. So from that resultant, you want to draw in your x component, draw in your y component. Theta is known to you. Resultant line is known to you. So solve for x sub 1 by going adjacent, cosine. Solve for y sub 1 by going opposite, sine function. Okay, so like for instance here, clearly I drew a bow tie triangle. From that bow tie triangle, your x sub 1 equation would be x sub 1 equals cosine theta times xr1, the first resultant's magnitude. And then your y1 would be y1 equals sine theta times xr1. Okay, so then you're going to say, then Sally wakes up the next day and Sally decides to now walk 16 kilometers in the direction of 60 degrees east of west or whatever. So you would draw your second triangle knowing that you are given the resultant using x, well, it's a bow tie here. So using x as cosine theta times resultant and y as sine theta times resultant, then you'd solve for x2 and y2. Step number 3 is getting your x total and your y total. So you're going to do x1 plus x2 equals x total, and then you're going to do y1 plus y2 equals y total. Once you get your x and y totals, then you're going to draw the new triangle out. You want to draw the new triangle out. Well, okay, Miss Arter, I totally get that you want me to draw my x total and my y total as my two new triangle component sides, but how do I know which one to draw first? Do I draw my x component first, or do I draw my y component first for my new triangle, i.e. step number 4? Well, thanks for asking. What you do is look at the first vector on day 1. So let's look back up here at this triangle again, okay? See where I am? So let's look at this triangle. In order to make this resultant line, okay, in order to make this resultant line, did you have to first travel x or did you have to first travel y? Seriously, stop and think about it. In order to make that blue resultant line, did you first have to travel x or did you have to travel y? Well, you first had to travel x. Well, since you first had to travel x, then that would mean that x total is what you want to draw first. So the way that you figure out, do I want to draw x total first or y total first for my new step 4 triangle, is you ask yourself, looking at my day 1 triangle, which x or y vector did I draw first? If you drew x first, then x total should be drawn first. If you drew y first on your day 1 triangle, then y total should be written first. Make sure your signs make sense here too, guys. Like let's say you get a positive x total but a negative y total. If you get a positive x total, you should be heading towards the east or towards the right. And then south or down, since your y total was negative. Once again, please make sure that since these are vector quantities, you are both taking magnitude and direction into consideration throughout the entire problem. Okay, so step number 5 then, now that you know what your new triangle is, you're going to use Pythagorean theorem to solve for magnitude, which is your x squared plus y squared equals r squared equation. And you're going to use the inverse tan to solve for your direction. Once again, I have to be very blanketed here and say the inverse tan of opposite over adjacent. If it's the inverse tan of y over x, you drew a bow tie triangle. If it's the inverse tan of x over y, then you drew an hourglass triangle. Okay, so let's actually jump into the problem and see what you guys drew here. So what this problem says is that a hiker is first going 27 kilometers, so that's XR1, from her base camp at a theta 1 of 35 degrees south of east. Well, that's negative 35 degrees right there, negative 35 degrees. So your day 1 triangle, notice how I'm doing that, day 1 triangle is you have east and then you have south. So here's your theta 1, here's your positive x1, here's your negative y1 that you're going to solve for, and here's xr1. Okay, she then walks, xr2, 41.0 kilometers, and your theta 2 is 65 degrees north of east. Let me put this in here real quick just to be specific. Okay, so your day 2 triangle is then going to be 65 degrees north of east. So you go east and then you go north. Theta is always placed in between the first vector drawn and your resultant line. So the first vector drawn was my x direction. See, this is my first one drawn, and here's my resultant line. So theta is going to be placed right there. All right, dressing this one up a little bit more, we can see that we have a positive x2 that we'll solve for and a positive y2 that we'll solve for. And here's xr2 that you should know about. Let me be more specific there. Okay, so you ultimately then you're trying to figure out your, I'm just going to call it xr in kilometers, and you're also trying to figure out theta in degrees. I don't know. It's either going to be north of east, south of west, etc., etc. So we don't really know yet, so let's just put lines there. Okay, so step number 1 said that you had to solve for your x1 and your y1 components. Guys, check this out. What did you draw? Did you draw a bow tie or an hourglass triangle right here? Look at it. Did you draw a bow tie or hourglass? You have an hourglass triangle. Or I'm sorry. Yeah, Miss Arter. You have a bow tie triangle. So on this bow tie triangle, that means x sub 1 is going to be which trig function? Okay, bow tie x you want to use, well, look at it. How is x in relationship to theta? X is adjacent to theta, so that would be cosine theta times resultant. Okay, get your calculators out. Don't just wait for me to do this for you. So that should be a cosine of a negative 35 times 27.0. Negative 35 and 27.0 is going to give you 22 kilometers. So x sub 1 equals 22 kilometers. All right, y sub 1. Y is opposite, so that would be the sine function. So sine theta times xr1 is going to be sine of negative 35 times 27.0. So that is going to give you negative 15 kilometers for your x of 1. Okay, let's move over here. Check out number 2, day 2, quote-unquote triangle. It's another bow tie. So x sub 2 is going to be cosine theta times xr2, whereas cosine of 65 times 41.0 is going to give you 17. So x sub 2 is 17 kilometers. Y sub 2 is going to be sine theta times your resultant. So that is cosine of 65 times 41.0. Putting that in your calculator, you should see 37. So y sub 2 equals 37 kilometers. Okay, so now we need to insert a new page here, and let's move on to step number 3. Step number 3 was get your x total and get your y total. Okay, so this is going to be 22 plus 17. So your X total comes out to be 39 kilometers. All right, Y1 was a negative 15 and Y2 is a positive 37. So Y total comes out to be 22 kilometers. Step number 4 is draw your new triangle. Okay, to draw your new triangle, we need to look back at day 1's triangle. In order to make day 1's triangle, in order to make this resultant line right here, guys, how did you have to travel first? Did you do X component first or Y component first? You had to do X component first. So that would mean for your new triangle, you want to go a positive 39 and a positive 22. So here's the theta that we're trying to solve for. Here's the resultant we're trying to solve for. Here's X total. Here's Y total. Step number 5 is your magnitude. To solve through for your magnitude, that is going to be X total squared plus Y total squared equals R squared. So the square root of X total squared plus Y total squared equals R. In other words, the square root of 39 squared plus 22 squared. Put that down in your calculator. 39 squared plus 22 squared equals square root, second answer. Should get roughly 45. So 45 kilometers equals X sub R. That is your resultant magnitude. Okay, how about direction? Direction is going to be the inverse tan of opposite over adjacent. Looking at your new picture here, step number 4, who is opposite and who is adjacent? Is it inverse tan of X over Y or inverse tan of Y over X? Well, since you created a bow tie triangle, it should be Y over X. So that would be the inverse tan of 22 divided by 39. Please stick that in your calculators. Inverse tan of 22 divided by 39. I should roughly give you 29 degrees. Okay, guys, now look at this 29-degree triangle. Here's your coordinate plane. So you got north, east, south, west. So what cardinal directions do you want to apply to this? You went north of your eastern line. So 29 degrees north of east. You went north of your eastern line. Okay, fantastic. So this is how you're going to solve through for your practice C problems. You need to break it into, first I did this, so solve for x1, y1, and then I did that, solve for x2, solve for y2. So ultimately, how far did I really travel and in what direction? So then step 3 would be x total equals, y total equals. Step number 4 would then be draw the new triangle by knowing the first vector drawn on day 1 triangle. Was that the x vector? If so, then write x total first, or draw x total first. If not, do y total first. And then use Pythagorean theorem to figure out the magnitude, and use inverse tan, opposite over adjacent, to figure out the degrees, your direction. All right, so please look at the Chapter 3 practice problem answers to see that you need 8 final answers for practice C. And please come to class prepared with questions tomorrow so we can assess where are your questions on this, not just math-based, but looking at the notes so far. Check your little boxes there, like where do you have blanks or where do you have questions on this stuff. Totally happy to help you guys, but be proactive. Let us know where your questions are. Good luck with these problems. We'll see you tomorrow.